Hi there, everyone. My name is Chris Fregley. I'm here to talk about generative AI and large language models. I'm a principal solution architect on the AWS side. I focus on AI and machine learning. We've got a lot of great stuff to talk about, so I'm just going to get right into it here. We're going to talk about reinforcement learning and GPT-3 and ChatGPT, how to get human feedback into these models, these very, very large language models. The GitHub repo for all demos that I'm going to show today is at the bottom there. Feel free to track that down and submit a pull request if you're interested. Here's the high-level agenda. We'll cover these 5 points here: generative AI, large language model overview. We'll talk about a very, very brief history of natural language processing. We'll also talk about how to build an end-to-end generative pipeline. So this is a pipeline that can train and fine-tune generative AI models, and specifically large language models. We'll show how to use reinforcement learning, and we'll show how to actually use human labeling to make these models much more effective. We'll cover this concept called prompt engineering that's really been getting quite a lot of press recently, and instruction fine-tuning. So all this should make sense by the end of this talk. Let's start with the overview. So now our focus today will be code generation and text generation. So these will all be language models. However, there's a huge field on the image generation and, of course, video, audio generation, all the multiple modals, right? Like multimodal is the term, where you could actually cross between these. And so let's get right into what is a large language model. So these are foundational models is another term that's used to describe these. And I should be clear, foundational models are not just language models. These large language models are a subclass, if you will, of a foundational model. But there's also image foundational models, video foundation models, that kind of thing. These are hundreds of billions and trillions of parameters that make up these models. So this is not the like linear regression models or the XGBoost models that we typically use throughout the day for a lot of our machine learning tasks. These are billions and trillions of weights that have been learned from human language. Now, the term foundational is key. I'll get back to that here in a bit. These sort of generalized foundational models are a little bit too generic in some cases. So while they are pretty cool in that they could support multiple language tasks like summarizing text, question answer, simple question answer, or even dialogue, chat dialogue, they're often out of the box trained a little bit too generically. And so that's why the next step will show how to customize for your specific data set and for your specific task that you're looking to do, or set of tasks. One of the coolest tasks that I personally benefit from on a day-to-day basis, as of just a few months ago, is source code generation. And this is, so let's actually demo this now. This is actually a product that comes under the name Code Whisperer. This is Amazon Code Whisperer, and I'll show you, I'll just give you a quick live demo here. Why wouldn't it know Spark? Spark's been around forever, and there it is. So read CSV data with Spark, include the header. There's header equals true. It knows that I'm not specifying a schema, and it's then calling infer schema. Show the first 10 rows. Why not? Let's do it. Boom. Fills in the 10 right there. Write that CSV out to Parquet with the overwrite mode on. I always forget what that overwrite flag is or how it's constructed. And then I can read it back in. Oh, and I can convert it to pandas. Boom. And there we go. So this is a decade ago. This is more than a decade because we're in 2023. This is January of 2013. We started seeing some of these early language models. Word2Vec, we were looking at pairs of words and n-grams of words, 3, 4, 5, 6 groups of words. Then we started to look at characters and groups of characters, and that gave us a little bit more of a finer grains, a little bit more space to explore and to potentially do translations and fun things like that. And then June 2017 came the Transformer, and Transformer changed everything. And if you do get a chance, you could read this paper. It's kind of a fun, memey title. Attention is all you need. The T Here, of course, stands for transformer. Now, let's fast forward to July 2018. GPT comes out. And of course, this is the foundation. This is the early version of what we know now today as ChatGPT and GPT-3 and ChatGPT-4 that like just recently came out. BERT, also the T in BERT is transformer. So all of these things build on this paper from 2017, and transformers really have remained untouched at their core, for the last 6 years. And people have tried to modify the transformer, and they just keep coming back to the original sort of implementation. Now, let's fast forward to get into sort of the last few years here. GPT-3 was June 2020, 175 billion parameter model. This is fantastic. A whole bunch of models came out about a year later that the ones in red are the open source model, 6 billion parameters, 20 billion parameters. Meta came out with one called OPT that I like a lot. That has 175 billion parameters. So seems to be tracking similar to GPT-3. And then Bloom. Bloom was a project out of a company called Hugging Face in conjunction with a bunch of researchers. I'll talk more about Bloom in a second. All of these really are variations of GPT-3 and perhaps fine-tuned a little bit differently. We'll talk about that here in a bit. And then, of course, ChatGPT and GPT 3.5, which ChatGPT is technically based on. There's one other one I do want to call out, InstructGPT. It's January 2022. It's approximately in the middle of the screen. It's a smaller model, but the instruct term we will talk about here in a bit. Okay, so we're going to fine-tune Bloom later. We're going to give it instructions similar to InstructGPT. But, just because I know you can't wait to get to it, we'll get right to ChatGPT. ChatGPT and InstructGPT, these are sibling models. Okay, so backing up a sec, InstructGPT, January 2022. And then ChatGPT actually builds on the research that the OpenAI folks had done for InstructGPT. Now, while that's a smaller model, it's been given a whole bunch of prompts and then responses. And prompt is a generalized way to say question. Okay. So question response prompts are more general than questions, however. They could be instructions. They could be go book something on Airbnb. They could be, book a hotel. They could be get me a flight. Okay, so ChatGPT has been trained on lots and lots of text out in the wild, and code. So I had just previously shown Code Whisperer, which has also been trained on code, and ChatGPT is capable of generating code. It's really cool. But just know that we don't know exactly how ChatGPT has been trained. Only the OpenAI folks know this. But I'm going to walk you through all of the steps that have been described in the ChatGPT papers and blog posts and all the OpenAI, at least public webinars and public talks. So we feel like we're pretty close to what they've been doing. I will mention that InstructGPT, right, has been given these prompts, like I said, questions, answers, right, like commands and then responses. But this also introduced this concept of what's called reinforcement learning and human feedback, RLHF. You'll see that term quite a bit throughout the rest. RLHF is a way to further fine-tune these instructed models and these generalized language models to improve helpfulness, improve honesty, truthfulness, right? We want the truth. We don't want made up things. And reduce harmfulness, or said differently, improve harmlessness. This is often called Triple H. And this maps directly, by the way, to the ChatGPT user interface you see in the upper right. When you thumbs down a response that ChatGPT gives you, you can say whether or not this is harmful, whether or not this is not true, right? That's the honesty. And then so whether or not this is helpful. So on those three axes, helpful, honesty, harmlessness, this is what we're trying to optimize. And we'll show how to use reinforcement learning to make those tweaks. And also, by the way, I'm going to hint something. Not everyone's definition of helpfulness or honesty or harmful harmlessness is the same. And so by having these ways to tweak that sort of last mile reinforcement learning, like model, I can actually see a future where we're creating personalized models, right? So maybe my version of ChatGPT or has been tuned slightly differently because I have a little bit higher tolerance for like harmlessness. I don't have any tolerance for that, or harmfulness. I don't have tolerance for that, but maybe something is a little bit more helpful to me because I don't expect the answer to be exact. I just want to know generally what is the answer. So, okay, but yeah, let's keep moving. And so ChatGPT is a sibling of InstructGPT, came later, used the research from InstructGPT. Here's a very funny and clear example of how GPT has improved in just 3 or 4 months here. Yeah, actually 2 or 3 months. So a very famous scientist, Andrew Ng, he had asked ChatGPT for, what's faster, CPUs, GPUs, for a given computation specific to deep learning. Well, of course, ChatGPT back in December seemed to think that CPUs are actually faster, which we all know, so this is not helpful. It's not necessarily harmful, although maybe it is harmful. Maybe this could have sent me down a path that I didn't expect to go down, and maybe I started telling friends, and now all of the people on my block think that CPUs are GPUs, and they think, or are faster than GPUs, and now my neighbors think I'm crazy. But since then, February 2023, this actually got better, and now the answer makes a little bit more sense. It's also much more concise. It's not babbling as much. Okay, so these are the kinds of things. So this is a case where likely, now we don't know for sure, but likely that last mile reinforcement reward for truth and for helpfulness kicked in, and with human labeling, which we'll talk about, made this answer better. And by the way, real quick, this potentially could have been improved by a whole bunch of people clicking thumbs down on the original Andrew Ng's response from ChatGPT. People could have asked the same question and thumbs down and put in what a proper answer would have been. And presumably the ChatGPT service is taking all this data, making little tweaks to those reinforcement learning reward models, and then taking the full answer that maybe somebody put in there and trying to figure out what actually is a more helpful answer. Okay. So we're already starting to see human feedback, right? This is actually human feedback from the masses, from all the people using ChatGPT. I think last I heard there was 100 million people signed up in just 2 months for this service. Pretty incredible. All right, this is a very famous set of like images that you'll see. I've cited the sources here. This is actually from the InstructGPT paper out of OpenAI. Really, all talks that come down to ChatGPT that are of any depth, 200, 300, always include this. And what's happening here is there's actually different levels of human feedback and different levels of fine-tuning. And so I'll mention fine-tuning over and over. The reinforcement learning stuff doesn't really kick in until steps 2 and 3. Step 1, we will dive into next. This is where we are actually going to instruct our generalized GPT-3 model, which the open source version is called Bloom. And we are going to give it prompts and responses that instruct that general model to be a little bit more fine-tuned. So this phase is called supervised fine-tuning. It's a term you've probably heard before. There's just a fancy acronym for it now, SFT. Okay, so there are technically humans involved, but I'll show you actually with some creative uses of historical data sets, the Amazon customer reviews data set that has a whole lot of data. It has reviews, it has star rating, which is ultimately sentiment. We can train a reward model in step 2 that can say whether or not a generated review, let's say we're going to generate reviews, which is kind of silly, but just work with me here. If we do generate reviews, we can actually ask that reward model that's been trained on those 150 million reviews, what is that generated review positive? Is it neutral, or is it negative? Meaning, is it happy? Is it, sort of angry? And maybe we prefer something a little more positive. And I'll show how at the very end, we can actually generate multiple reward models that are specific to users and to their specific tolerances, or even parts of the world, parts of the country. Okay, so all of this we will visit in separate pieces, so I'm just going to keep going. Now, given that we have 150 million of those reviews, which, by the way, is human feedback, it's just feedback that happened 20, 30 years ago, right? Since 1995 to 2015. But we could reuse that human feedback in an offline manner, and we can templatize. So there's something called a prompt template. And what we're trying to do is create those prompts and the responses that we're then going to use to instruct that generalized language model called Bloom. Okay? So we end up turning this into a classification task. Maybe sentiment analysis really is the easiest way to say it. All right. The context here is that we are going to fine-tune a generalized language model. We're going to give it prompt instructions from the prompt database that we will construct during this process that I just showed you with those templates. It's very important to note that this model has not yet been fine-tuned on our specific prompts data set where we're asking it to classify. So the one I'm going to show today is I want to use generative AI to classify my reviews as a star rating 1, 2, 3, 4, or 5. This is crazy. Why wouldn't I just use a classifier? Well, you certainly could, but let's just work with this here and see how far we get. Okay, here's the demo I'm going to show. Now, I've already run the code because it does take a bit of time to run. And I'm going to summarize here. We have a generalized Bloom model that does not know about the instructions that we're giving it. We're then going to give it a whole bunch of data. Actually, I should be clear, we're not even giving it that much data. We're going to give it about, I think, 25 examples. So 25 rows of data, 25 prompt and responses. And I think we fine-tune the model for about 3 minutes. And before the fine-tuning, which was 3 minutes and only 30 examples or 25 examples, this model, because of its deep understanding of the human language, was able to adapt to the prompts, to the instructions, and start to give me valid responses. So the first time I did this with just generic, or with the generalized Bloom model, it just responded with the word if, which is not what I'm asking it to do. After fine-tuning it, giving about 10 examples as part of sort of a fine-tuning training process, it was then able to give me a valid response. And so this is what I'm going to be calling for the rest of this talk, the instructed large language model. All right, let's jump over to some code here. So let me zoom in one more time. I always make it a habit of zooming in one more time everywhere. Okay. Here, by the way, is how we apply. So this is our data set. This is a small cross-section, only 145,000 rows. This is the Amazon customer reviews data set specifically for digital video games, just a fun one that I chose. Here's the available prompts. I had shown you, I think, 2 or 3 of these earlier. We're selecting a prompt, given the review body, return a categorical star rating. The available answers are 1, 2, 3, 4, 5. This all comes from a library that was open sourced by Hugging Face during the big science effort that's called Prompt Source. And, I'll be very honest with you, it's pretty simple. It's just Jinja, which is a Python library that does templating. And they just crowdsourced a whole bunch of prompts and a whole bunch of responses. And actually, the responses come from our data set. So the prompt engineering part of this was the linguistic task of trying to find different ways to ask a similar question for the prompt that will give similar answers. And by doing this, with just 5 different prompts and slightly different wording, we can get what we're trying to get here, which is a star rating 1 through 5. Okay, here's the actual template here. You even see the word Jinja. So I'll skip through here, but I do want to show, okay, this run through, this gave me the word the. Now this is before fine tuning. Okay, training this for only 3 minutes and on 27 examples, I can actually improve the quality of this model. So now on a zero shot, which is meaning I'm not even giving it any working example, I'm just asking it what's the answer to my prompt. On the first try, this comes back with the right. Now, I do want to build up the intuition that somebody probably has done this already. And it's very likely, of course, Hugging Face created Bloom and Hugging Face created prompt source, which was the Python library that I was using for the Jinja stuff. And so all it took was one extra, Google search to realize that there's already a variant that's been trained, not just on, or that's been instructed, right? That's been fine-tuned with instruction, not only on the prompts that I was just showing you, but on many other prompts, on news article summarization, on all these other things. So you can look something up called XP3. That's the name of the project for all of these different prompts. It's essentially a data set, but BloomZ has this. So I think this previous slide I showed my instructed LLM. Well, I spent a little bit of time training that, and then I discovered that BloomZ already does this and much, much more. So I'm just going to use BloomZ from now on. Now, if you have your own custom data set, your own private data set that's not the public Amazon customer reviews or the public news, then you do have to go through this fine-tuning phase. But just wanted to make that clear. Okay. Now that we've created the instructed variant of our model, fine-tuned variant, let's fine-tune further on 3 more axes, right? For the helpfulness, for the honesty, and for the harmlessness. We're going to do that with reinforcement learning. So this is what we have today. I'm keeping my instructed LLM here just for the case where you have private data. It's a little bit easier to think through and not necessarily use BloomZ. And so now we go into step 2. This is part of that full pipeline that I had shown earlier. Step 2, we are bringing humans back in. So if you notice, here, humans were just part of that initial part. Really, that was from the Amazon customer reviews, or maybe your historical data set that you have from your intranet, or some other source of text. Maybe emails, maybe Salesforce, tasks and comments and notes and things like that. But here, we are actually going to sample prompts, or specifically sample responses for prompts that are coming out of my newly instructed and fine-tuned LLM. And I'm going to let humans decide. Step 2 are actually curated knowledge experts in a particular domain who can rank these responses that are coming out of this model. And I'll sort of hint at something I'm going to talk about at the very end, which this doesn't have to just be a single model. I could actually generate 4 or 5 different, let's say 4 variants of the instructed LLM that's been fine-tuned slightly different with slightly different prompts maybe, or with a slightly different data set. And I'm going to then generate 4 different responses, 1 from each model. Okay, here I'm saying 4 responses from a single model. 1, 2, 3, 4, the human ranks them. And ultimately, the goal for step 2 is to output a reward model that is along one of those dimensions of helpful, harmful, and like honesty. Now, the output of step 2 is a reward model that's then going to be used as part of reinforcement learning. Now, reinforcement learning is actually pretty straightforward. But the real key is the reward model that feeds in to the reinforcement learning. And so, why we're using reinforcement learning here, there's some skepticism or some, not necessarily controversy, but different folks have different ideas of the usefulness of the reinforcement learning. In my opinion, the reinforcement learning gives us that sort of last mile capability to personalize these models to a particular end user ultimately. Maybe not right now, maybe we haven't gotten to that point where I have my own personalized set of like reinforcement models, like reward models, and then like chatbots that are specific to my tolerance of helpful and my tolerance of harmless and honest. But that's where things will likely go. Okay. Because we are dealing with humans. Humans are the ultimate end user of these chatbots, and we, at some point, do want to be able to, turn some extra knobs. And so that's really the power of these reinforcement learning, and they can change a little bit quicker than some of the earlier phases. And so, okay, so yeah, let's keep going. And then the step 3, we have a holdout data set that's not been seen by step 1, step 2. We are then going to generate prompts, for a given prompt from this holdout data set, we are going to generate responses that will be scored by the reward model, or, hinting ahead, could be potentially multiple reward models, one for helpful, one for honest, one for harmless, that would then be ensembled together to say whether or not this response is appropriate for this prompt for this particular user. Okay, so the output of step 3 is an instructed and helpful like large language model. And that's what's actually the chatbot, okay? These reward models are just binary classifiers. They're saying for this prompt and this response, is this positive or like helpful? Is it neutral? Is it not helpful? And of course, that data was trained from those thumbs up, thumbs down, and from those buttons and from human labelers, right? And like I was hinting multiple times here throughout, there could actually be multiple models at every single step of this fine-tuning process. The instruction fine-tuning, the Triple H fine-tuning, and even the reinforcement learning models. Okay? So I believe that's it. The key takeaways here, generative AI is here to stay. Large language models have actually been around for a while. They're just now getting to the point where we can turn those knobs and make them both helpful, honest, and harmless. You want to make sure that you're fine-tuning on instructions. That would be using prompts and also Triple H. Quick note on code generation. I love it. I don't feel like it's going to take my job. I actually feel like I write better code because of it. I realized the other day when I was doing some Spark code that I actually was using an older style of Spark, because of back when I learned Spark was like 2013. There's newer ways to do things. There's newer APIs, and the like autocomplete through Code Whisperer actually gave me the better implementation, and I've now changed the way that I think about some of that Spark code. Reinforcement learning, human feedback, these are absolutely critical right now at this stage. We need the human feedback to keep the alignment with human values, to keep these things from being toxic, and to maintain honesty. We don't need that much data to actually fine tune. So I showed you 27 prompts, and 3 minutes gave us a model that was very, very useful, right? And the other big takeaway, something I learned from this process of using these models over the last 6 months or so is, really try out the existing fine-tuned models. Just do an extra Google search to see if somebody else has a model. Of course, be careful where you're getting it from. For the most part, if you go to the Hugging Face Hub, right, like Model Hub, Dataset Hub, very, very, curated, very good, safe place to go for your models. And I think that's it. Thank you very much. The code can be found here and the URL at the bottom. I'm Chris Fregley, and have a great day. Thank you.